All right, today we're going to be talking about how to multiply polynomials. Up until now, we've talked about how to name them, how to classify them, how to add them, how to subtract them. But now we're going to talk about a couple of different ways that we can multiply them. Okay, so our essential questions. The first one, how do I multiply polynomials? And how do I use binomial expansion? Binomial expansion is going to be the new thing for us today, okay? And you're probably going to want a calculator. All right, whenever we are multiplying polynomials, what we normally do is we distribute every term. Up until now, you guys have probably used the FOIL method. Remember when we did first, outer, inner, last, and then combined our like terms? Or some of you may have preferred the box method, which is perfectly fine. Remember, two binomials make a trinomial. When we multiply two binomials, we're going to have to combine like terms, and it makes a trinomial. Okay, so our first example, we have 2x, which is a monomial, being multiplied by negative 2x minus 3. So what we need to do first is we need to distribute this 2x to each term in the parentheses. So I'm going to say 2x times 2x, times negative 2x, I'm sorry. So positive 2 times negative 2 is going to give me a negative 4. And then x times x is going to make x squared. Now I've got to distribute this 2x to my second term in the parentheses. I've got to say 2x times negative 3. So positive 2 times negative 3 is negative 6. But now there's nothing else that I can multiply with this x because negative 3 doesn't have an x. So I'm just going to bring my x on down. Then before I say I'm done, I just make sure I don't have any like terms. I have a negative 4x squared, and then this one is just x to the 1, so no like terms. So my final answer is right here. Negative 4x squared minus 6x. All right, let's try us another one. All right, now this time I have a binomial, meaning it's got two parts, binomial times another binomial. Okay, now there's two ways that you could do this. You could either use the FOIL method, first, outside, inside, last, or you could do the box method, which is a whole lot like the Punnett squares that you did in biology. Okay, either one will get you the right answer. Let's do the FOIL method for this one. First, outside, inside, last. So what I'm going to do, I'm going to get rid of these. I'm going to get these out of our way. So if we're going to multiply the first term in each set, 3m is listed first in this set, 8m is listed first in this set. So 3m times 8m, 3 times 8 is 24. M times m is m squared. Okay, that's my first. Okay, now we've got to multiply the outside two together. Okay, like if this were a sandwich, they would be the pieces of bread. So my two numbers on the outside would be 3m times 7. See how they're kind of the bread of the sandwich? So 3m times 7, this is my outer terms. 3 times 7 is 21. M doesn't have anything to be multiplied with, so it's just going to be a 21m. Now 21 is positive, so let's just put a plus sign. Okay, we've done first, we've done outer. Now we've got to do inner or inside. Okay, that would be kind of like the peanut butter and jelly in your sandwich. There's what's on the inside. Okay, so I've got -1 times 8m. So -1 times 8m is my inner. So -1 times +8 is -8m. So we've done inner. Now we got to do last. So that would be my two terms that are listed last in each set. So in this case, I've got -1 is listed last and 7 is listed last. So -1 times 7, -1 times 7 is -7. So then we've done our last. Now before we say that we're done, the last thing we got to do, we got to make sure that we've combined all like terms. So I've got 24m squared. Well, there's no more m squareds in that thing. So I'm just going to bring that on down to my final answer. Now I have two terms in the middle that are both just plain m. So 21 minus 8, what's that going to give me? 13? And then nothing else goes with my -7, so I just bring that down. All right, now let's try this one using the box method. Now to do the box method, all I do is I just take my first two terms and I just write them going horizontally. 2a minus 1. Then I go and I grab my second terms, my second set, and I'm going to write them going vertically. 8a minus 5. Now, the reason we call this the box method is because after I write my terms horizontally and vertically, I'm just going to make a box. And now I'm going to draw a line down that splits these two terms. And I'm going to draw a line that splits these two terms. Now, just like back whenever you were first learning times tables, we're going to have to multiply whatever meets up in each box. So if we're looking at this box right here, what meets up there? I've got 2a times 8a. 2a times 8a. So 2 times 8 is 16. And then a times a is a squared. Now I move out to my next box. Looking right here. The terms that meet up right here that we multiply, I've got 8a times -1. So 8a times -1 is -8a. All right, moving down, got my next box. Right here, my two terms that meet up, I've got -5 and 2a, so -5 times 2a is -10a. And then in my last box, I've got -5 times -1, so negative times negative is going to make that a +5. Well, there's all my terms, but now I got to simplify because I got some like terms that kind of fall right here in this old peanut. So combine my like terms. Well, nothing combines with the 16a squared, so that's going to be in my final answer. And then I've got negative 8a and negative 10a. If I add those together, that's going to be negative 18a. And then I don't have anything that combines with my 5, so I just write plus 5. So that's our box method. And guys, you can choose. Do you want to use full or box? I don't care. You'll get the same answer either way. All right, one more example, and you can choose whichever method you like the best. I'm going to work it out right here. 4n times 2n, 4 times 2 is 8n squared. 4n times 6 is 24n. 1 times 2n is 2n. 1 times 6 is 6. Now to finish this up, I got to combine my like terms. So my final answer is going to be 8n squared plus 26n plus 6. Okay. Hopefully we don't have any questions at this point, because I know that you've done this before. You did all these probably for the past 2 math classes that you've taken. Now here's where you're going to learn something a little bit different, because it's not always as easy as box or full method. Okay, here's something new. Do you know how to multiply x minus 5 squared? Of course you do. You could have done that, because doesn't this mean the same thing as x minus 5 times x minus 5? And we can rock and roll with that all day long. Okay? Same thing. Okay? But what if my exponent had been higher? X minus 5 to the 5th power. That's going to look a little bit different. Doesn't that seem like a headache? Because if we were going to use the methods that we already know, we would be saying, okay, x minus 5, we would box or full here. And then whatever we got, we would box there. And then another box method. And then another box method. And that's probably going to take up a whole sheet of paper. Okay? Here's a shortcut way. We're going to learn the binomial theorem and talk about Pascal's triangle. Okay? Pascal's triangle. Okay? It's a pattern, is all it is. The first and the last numbers in every row are 1. Okay? As you can see, we've got 1s going down here. We got 1s going down here. That will always be true. We'll always start with a 1 at the top, and then there'll be 1s going down both sides. Beginning with the second row, every other number is formed by adding the 2 numbers immediately above that number. Okay? Here's what I mean by that. And I'm going to get these lines out of your way. Here's what I mean by that. Okay? Notice this is row 0. At the top, that's like the star at the top of the Christmas tree. That's row 0. Then we come down, we got our first row. And then second row, well, our second row has got this right here. We got to fill in this blank. And the way that we do that is we add the 2 numbers that are directly above it. So we get the 2 by saying 1 plus 1. Then we move down to our next one. It's got 2 blanks, and I know I hit the button a little too early. We get our next blank is 3. That's by adding 1 plus 2 equals 3. Now we've got to find our next blank. 2 plus 1 is another 3. Then we move down to our bottom row. Okay, we got to find 3 terms this time. But it's still made the same way. 1 plus 3 makes 4. Then we go to our next number. 3 plus 3 makes 6. And then 3 plus 1 makes 4. Now, we write the 5th row of Pascal's triangle by adding the 2 from the 4th row. We write the 6th row of Pascal's triangle by adding numbers from the 5th row. So if we keep on going, keep on filling it out, and I know y'all have figured out this pattern by now. 4 plus 1 is going to give me 5. Then we work our way on down. 1 plus 5 is going to make 6. 5 plus 10 is going to make 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. Notice there's a pattern there too. 1, 6, 15, 20, and then it works its way back down. 15, 6, 1. It's like a reflection over there. Now on your paper, you can complete the 7th row. Now this is what it looks like if we go ahead and fill it all in. Now remember, the star at the top of our Christmas tree, this guy, that's row 0. Then row 1, row 2, and so on. That's one big thing that people mess up. Because here's why we need to know this, okay? Using Pascal's triangle, this somewhere. Okay, using Pascal's triangle, and we know this is row 0, row 1, row 2, row 3, row 4, and row 5. Here's why that's important. Okay, x plus y to the 0 is equal to 1. Because, okay, this right here tells me I'm looking at row 0. So if I go over to row 0, the only thing in row 0 is 1. So anything to the 0 power is 1. But y'all already knew that rule. Okay, let's say I've got x plus y to the 1 power. Okay, that means I'm going to come over, I'm going to get 1 and 1 as my coefficients. And then I have x on the left, and then y on the right. Okay, now this next one, we're working our way up. All right, this one's telling me to look at row 2. So if I look at row 2 over here, my coefficients are 1, 2, and 1. That's where these came from. 1, 2, and 1. Because this tells me to look at row 2. That's where the 1, 2, and 1 came from. Now, x is the coefficient on the left. So I'm going to be doing x to the 2nd power, and I'm going to start on the left. So it goes x to the 2nd, and then I work my way down. X to the 1, it's like a countdown, like New Year's Eve. 2, 1, 0. I don't have an x right here. But now it's kind of like spring break. You get to go to the beach, but then you always got to come on back. So we got to come on back from the right-hand side. Now, y is on the right-hand side. So I'm going to say y squared, and then count down again. Y squared, y to the 1, and now I've run out of y's. I don't have a y on this one. Before you go in freak out mode, the higher the row number gets, the easier this gets to see the pattern, I promise. All right. let me get some of this stuff out of the way so you can see. Okay. All right, start now. X plus y to the third power. That means go to Pascal's triangle and grab row 3. Right here. My coefficients are going to be 1, 3, 3, and 1. Okay? That's because my exponent is 3. Now, x on the left. Okay? So I'm going to start with x to the third. x3. Okay? Remember, it's like a countdown. x3, x2, x1, Is Miss Adams? Hey, doing good. Katie did, yes. Okay. Okay, that one's going to come up different, and then Carlton Williams is going to come up different also. Okay, he took his, I think right after school the other day. Okay, okay. Yes, yes, yes. Why didn't this record? Oh my gosh, seriously.